a few tricks that I learned that makes things a little easier to remember as far as operations and things like that. Putting a number into scientific notation, we have the decimal. So when the decimal moves to the right, the exponent is negative, and the function is division. When the decimal moves to the left, the exponent is positive, and the function is multiplication. Just picking up like an arbitrary number here. Say we have 6.22 times 10 to the negative 2. That's dividing, but the only reason why they do that is because this looks a lot prettier than if we would do something like this. Again, the whole point of this is to make things a little less cumbersome. So, I mean, you have a multiplication here and division here, and we know from basic algebra that if you have a power or an exponent on the denominator, you can just pull it back up to the numerator and it becomes negative. So we would have 6.22 times 10 to the negative 2. So when we take a number that's in scientific notation and bring it out to a regular number, we do the opposite. So when we had a number and bring it into scientific notation, I'll just make a chart here. I'll put decimal for decimal. Expo for exponent. And we really don't need the function. I think we know what to do by now. But so starting here from putting numbers into scientific notation, when the decimal moves to the right, we have a negative exponent. When the decimal moves to the left, we have a positive exponent. And the exact opposite when we have them in scientific notation to pull them out to a regular number. So we would have, if the decimal moved to the right, we would have a positive exponent. And also if we had a decimal that moved to the left, we would have a negative exponent. So this is going from numbers to scientific notation, and this part is going from scientific notation to numbers. And you'll see a lot of things like this happen. There's really binary functions. There's not a whole lot of choices, like an acid or a base. That seems to be a common thing out here. So what I like to do is, if I can just remember one of these operations, like to put a number into scientific notation, if I just remember that, if I remember this, when I put a number into scientific notation and just remember this, the decimal moves to the right and the exponent is negative. If you just remember that part there, you can figure everything else out by eliminating options. When a concept has a binary choice, if you just remember one, you can find the other one out by knowing that it's not what you remember. Okay, so hold on. So what I'll do here is I'll take the number and put it into scientific notation. We'll complete that, and then we'll take that same number and go from scientific notation to a regular number. So here we have our number 70, 75. And then we go to the default decimal, and we want to bring it to where we get a single digit between 1 and 9. So we move it to the left, 1, 2, 3. So then we would have 7.075, and we moved it to the left, so it would be positive. And we moved it in increments of 10. This would take it down one increment of 10, and this would take it down another increment, and that would take it down to another increment. So we've got it all the way down to 7.075 times 10, and we moved it 3 positions, 1, 2, 3, and it's positive because it went to the left because we're putting it into scientific notation. So this part right here would bring this decimal part back up to its original magnitude from what it was initially. Now we have 7.075 times 10 to the third. And we want to bring this from scientific notation back to a regular number. So to do this, in this operation, we took the decimal left, and we had a positive exponent. So, and that was to go from a number into scientific notation. Let me write that down. So when we go from scientific notation to a number, right equals positive. And this is kind of like our coordinates of what to do with the decimal right here in the square. We're going to move it in increments of 10, and we're going to move it 3 times, and because it's a positive exponent of the exponential, we know that we move it right because we're taking it from scientific notation to a regular number. So 1, 2, 3. So now we have the number we started with, 7075. Just kind of summarizing what we went over. We took a regular number and put it into scientific notation. When we did that, we moved the decimal to the left, so it would be positive. When we moved it to the left, we decreased the magnitude by 1,000, so we had 7.075. So to get it back up to the magnitude that it initially was, we had to multiply it in increments of 10 3 times to bring it back up. Basically, all we're doing is we're taking the magnitude down, and then we're pumping the magnitude back up with this exponential and exponent. A number to scientific notation, moving the decimal left, was positive. So here we go from scientific notation to a number. So right would be positive. So we move the decimal 1, 2, 3 times in increments of 10 and bring it back to its original number. So looking at exponents with negative exponents, we'll do the same thing. We'll go from a number to scientific notation, and then we'll go from scientific notation to a number. So here we would move the decimal to the first whole number between 1 and 9, and it looks like we would want to go right here behind the 7. So we'd have to move it to the right 1, 2, 3, 4 positions. And when we're going from a number to scientific notation, right equals a negative exponent. So we moved it in increments of 10, 4 positions to the right. So we would have negative 4. So now we have 7.0 times 10 to the negative 4, and we want to bring it from scientific notation to a number. So we can just drop this down, and then I like to put the zeros down ahead of time so I don't have to mess around with it. So since we're going from scientific notation to a number, we're moving the decimal to the left, so the sign would be negative. So 1, 2, 3, 4. We want to go right here with it. What we just did was kind of just followed the coordinates of this part right here, and that's just telling us we're moving it in increments of 10, and we're doing it 4 times, and we're moving the decimal to the left because this is 0, or excuse me, that's negative. So 1, 2, 3, 4. 0.0007. So just kind of a summary of an outline of what we did. This helped me. I hope it helps you. So when we're going with a number to scientific notation, when we move the decimal, I'll just put decimal here. When we move the decimal right, the exponent is negative. When we move the decimal left, the exponent is positive. When we're going from scientific notation to a number, it's the exact opposite of what this was up here. And I mean, that's what we're doing. We're doing the opposite of what we did here. We're going from a number to here. Now we're going from here to a number. So, I mean, the operations would be the exact opposite too. So here, if we move the decimal right, we get a positive exponent. And if we move the decimal to the left, we get a negative exponent. What really helped me out a lot, and it really helps with time, is remember one piece of this. So I would know that if I move the decimal to the right, it's negative. So I'm moving the decimal left, so it's got to be positive. And then again, if I just remember this operation, numbers the scientific notation, the decimal moves to the right, it's negative. So when I move from scientific notation to a number, well, then it's got to be the opposite of what I remember, what I've got committed to memory. So I hope that helped you out.